The Tufts Research Experience is an academic year program that is open to high school juniors and seniors that is separated between the fall semester and the spring semester. Students will conduct research under active membership by Tufts world-class researchers and their teams. Throughout the course of this program, students will learn about laboratory techniques, research methods, and data collection and analysis skills. And while working with these research laboratories, students will be actively participating in not just the rigorous research activities, but all of the team meetings, individual meetings with principal investigators that are associated with the world of scientific research. By the program end, students will also have the opportunity to present their research findings in a virtual poster session for the fall.
So my research group is an inorganic and materials research group, and we're very focused on sustainability. So our main goal in that work is to develop new molecules and materials and routes to making them that provide some impact on problems such as climate change and the energy transition that the US and the world are undergoing in the next few years. So one area that we work on is new materials for thin film photovoltaics. So the thin film photovoltaics are an approach to converting sunlight into electricity and provides a clean source of power. About 30% of the photovoltaics installed in the United States are actually made by a US company for solar, which makes cadmium telluride cells. These cells use a very thin layer, 100 times smaller than a human hair, to convert the light into electricity. And so one of the hopes is to add other layers on top of this that can convert broader sections of the solar spectrum and bring the efficiency of those devices from about 20% of the light power turned into electrical power up to something more like 30%. At those percentages, it starts to be cost effective to install rooftop solar everywhere in the US or most places in the US. But new materials are needed in order to do that. And so my group works on new materials and new ways of depositing those materials that could serve as partner layers for existing photovoltaics. Another project in my group works on developing new molecules that could be used as the light emitting molecules in organic light emitting diodes. These are a new lower cost, lower power way of producing light from electricity. Instead of just resistively heating a tungsten filament, careful selection of some, again, thin layers of inorganic materials, in this case paired with some organic materials, allows emission of light across the visible region, so in a variety of different colors. Currently, 8% of global emissions, carbon dioxide emissions, come from manufacturing steel. Half of those come from the process of making iron from iron ore. And that process takes iron oxide, combines it with carbon to make iron metal and carbon dioxide. And so broadly speaking, one of the interests of my research group is how can we transition from the energy economy and the materials economy that we currently have to one that utilizes renewable resources such as solar or wind-based electricity and emits less or no carbon dioxide. This is one reason we're working on thin film photovoltaics. We want to provide that source of clean electricity. And the other projects in my lab, once you have that clean electricity, what do you do with it? And so providing light is one thing, providing materials such as iron that go into steel and make up large portions of the infrastructure of our buildings and ships and bridges is sort of an urgent crisis that without new chemistry, we're not going to be able to solve. We're not going to be able to transition our energy economy, and we're not going to be able to transition our materials economy to carbon dioxide-free routes without new chemistry. And so that's where my group works. The students were so excited and so bright and motivated, and they really brought a lot with them, both in their enthusiasm and in their ideas that drove a project forward that we had been working on for about 6 months at that time. We made more progress in the 6 weeks of the Tufts Summer Research Experience than we had in the preceding 6 months. And so for me, that's a very exciting thing from two directions. One, I love getting more science done. And two, it was really wonderful to share that experience with these high school students who were acting really as equal partners in the project.